Show that the points A, B, and C are collinear. Find the ratio in which B divides AC. Pause the video, give this a try. Okay, let's do this step by step. The first thing that we have to do is to prove that these 3 points are collinear. There are 2 ways to do this. Method 1 is to prove that AB vector and BC vector, they're collinear. And the second method involves distances. We can find the distances, find the magnitudes of these 3 vectors, AB, BC, and AC, and we can prove that AB plus BC is equal to AC. Alright, we'll not prove using method 2, we'll use method 1 here. So let's find AB and BC. AB vector is 5 minus 1 I cap plus 0 minus minus 2, that's 0 plus 2 j cap, plus minus 2 plus 8 k cap. So that's going to be AB vector. Now BC vector, that's going to be 11 minus 5 I cap plus 3 minus 0 j cap plus 7 plus 2 k cap. So AB vector is 4 I cap plus 2 j cap plus 6 k cap, and BC vector is 6 I cap plus 3 j cap plus 9 k cap. Alright, so we have these 2 vectors in their component form. Let's compare their components. We have 4 by 6, 2 by 3, and 6 by 9. The x coordinates are 4 by 6, y coordinates are 2 by 3, and z coordinates are 6 by 9. The ratios are 2 by 3, 2 by 3, 2 by 3. So all of them have the same ratio 2 by 3, which means they're in proportion. This means the direction ratios are in proportion. So this means that the vectors are collinear, which means that these points are collinear. Now on to the next part, find the ratio in which this divides AC. Alright, so let's visualize this. We have origin and we have this line segment AC. We have this point A and then we have this point C. This is A vector, this is C vector, and this line segment is being divided by this point B. Let's say this B sits here. So this vector is B vector. Now we don't know the ratio in which B divides AC. Let's assume that the ratio is M is to N. This is the ratio. This is A vector, this is C vector, and this is B vector. These are position vectors of these points A, B, and C. Alright, how do we do this? We can apply section formula here. A quick recap of where that formula comes from. We use these 2 triangles to find vectors BC and AB. And we've already proved that these vectors are collinear. So we write one of them in terms of the other and try finding the relationship between A, B, and C and M and N. So in this triangle, we have 2 ways to reach C. We can either go directly or we can go through B. So we can say that B vector plus BC vector, that's equal to C vector. And in this other triangle, we have 2 ways to reach B. We can directly reach B or we can go through A. So A vector plus AB vector, that's equal to B vector. Now we can rearrange and relate BC vector and AB vector. Because these 3 vectors are collinear, we'll get B vector that's equal to MC vector plus NA vector divided by M plus N. This is also called the section formula. This formula relates B vector which divides AC in the ratio M is to N internally. So what do we know? We know the position vectors of A, B, and C. And what do we need? We need the ratio in which B divides AC. So we need M by N. Alright, let's rearrange. We have B times M plus N, that's equal to MC plus NA. So let's plug in the values. M plus N times 5 I cap plus 0 j cap minus 2 k cap. That's the position vector for B. That's equal to M times C vector, that's 11 I cap plus 3 j cap plus 7 k cap, plus N times A, that's I cap minus 2 j cap minus 8 k cap. Alright, let's open this up. We have 5M plus 5N I cap plus 0 times M plus N, that becomes 0, minus 2 times M plus N k cap. That's the left hand side. On the right side, we have 11M plus N I cap plus 3M minus 2N j cap plus 7M minus 8N k cap. So we have a vector here on the left hand side and we have a vector here on the right hand side. And we're given that these 2 vectors are equal. Equal vectors have equal components, which means the x component here will be equal to the x component here. the y component here will be equal to the y component here, and the z component here will be equal to the z component here. So we have three equations. So 5m plus 5n, that's going to be equal to 11m plus n. That's first. Here we have 0. So 0 is equal to 3m minus 2n. That's the second one. And third is minus 2 times m plus n. That's minus 2m minus 2n. That's equal to 7m minus 8n. So we have these three equations, but we only need one of them. We need the ratio of m and n. We can use the simplest one. Let's take this one. So if 3m minus 2n is 0, we can say that 3m is equal to 2n, or m by n, that's equal to 2 by 3. This is it. That's the ratio that we need. The ratio in which b divides ac, that's 2:3. But what about these other equations, you might ask? You'll get the same answer for these two as well. Let's try. For the first one, we have 11 minus 5, that's 6m, equals to 5 minus 1, that's 4n. So 6m equals to 4n, or m by n equals to 2 by 3. Same result. Let's look at the third one as well. We have 7 minus 2 or plus 2, 7 plus 2, that's 9m, equals to 8 goes to this side, that's 8 minus 2, 6n. So 9m equals to 6n, or m by n equals to 6 by 9, that's again 2 by 3. So no matter which one you pick, you'll get the same ratio, m by n equals to 2 by 3. So that's the ratio in which b divides AC. Let's solve one more problem. Find the position vector of the point R which divides the lines joining P and Q, whose position vectors are 2a vector plus b vector and a vector minus 3b vector externally in the ratio 1:2. Alright, pause the video, give this a try. Okay, let's do this together. We have the origin. We have our R vector which is dividing the line joining P and Q externally. So here's P and here's Q. This is R vector, this is P vector, this is Q vector, and this line segment PQ is being divided externally by R. So R sits outside. The ratio is 1:2, which means PR is to RQ is 1:2. If this length is 1, this length is twice of that, that's 2. So the ratio is 1:2. And because we have external division, we are moving in opposite directions. We go from P to R in this direction, and then we come back from R to Q in the opposite direction. So how do we do this? Well, we can represent these two vectors in terms of P, Q, and R. If you have to look at this yellow one, this yellow vector, to reach Q, we have two ways: directly reaching Q or through R. So R vector plus RQ vector is equal to Q vector. And in this triangle, to reach R, we have two ways. Either you reach R directly or through P. So P vector plus PR vector, that's equal to R vector. And because these two vectors are collinear and we're also given the ratio, if you recall, for external division, PR vector by RQ vector, that's equal to minus m by n. The negative sign suggests that these two are in the opposite direction. And if you rearrange, you'll get R vector as mq vector minus np vector divided by m minus n. Now we can rearrange. We have m minus n R vector equals to mq vector minus np vector. Let's plug in the values. M is to n. So m is 1 and n is 2. So 1 minus 2 R vector equals to 1 times Q vector minus 2 times P vector. Now P vector and Q vector could be written in the component form, but they need not always be in the component form. This works nonetheless. So Q vector is 2a vector plus b vector. So let's substitute these values. Let's clean this up first. We have minus R vector equals to Q vector minus 2p vector, or R vector, that's 2p vector minus Q vector. Now P vector is 2a vector plus b vector, and Q vector is a vector minus 3b vector. Now simplifying this, we have R vector equals to 2 times 2, 4 minus 1, that's 3a vector, plus 2 plus 3, that's 5b vector. So R vector can also be written in terms of a vector and b vector. R vector is 3a vector plus 5b vector.